There were some questions on problem 1B.9, so I thought I'd make a short video. That I guess I'll show the. Here's the statement. It says, once more in figure 1.8, this one, let P be the intersections of points BY and CZ. So I guess this is the point P. Assume that AB and AC are equal, so this is an isosceles triangle, and that BY is equal to CZ, so BY is equal to CZ. We ask if it is necessarily true that PY is equal to PZ, so in other words, this piece and that piece, or else to show how to draw a counterexample diagram where all the hypotheses hold, but where PY and PZ are clearly different lengths. We drew figure 1.8 so that PY and PZ actually are equal, and so if a counterexample exists, it'd be necessary to have a look somewhat different from the figure. All right, so we have a sense of what's going on. So here's the way I thought of it. You may have tried to construct this, I guess, a proof of this, and found that it's really difficult to find a proof. And I think the reason it's difficult to find a proof is that it generally is not true. So the way that I thought about it was, well, draw in, one of these lengths. Let's call it CZ. So there's CZ, right? And then, the idea would then be to copy that length for B. So I'm holding my compass that length and trying to copy that length here to make sure I get the same thing. So it looks like this would be our point Y for BY. So this is the way the book has it drawn, so PY and PZ are both the same length, and it appears that they're the same length if I can trust my drawing here. But is there a way that I can get a length BY that's exactly, let's call this Y1, BY2, where and let's call this P1, where the length of this is definitely shorter or longer than the length of that. And I think it kind of makes sense that when you draw it this way, that if I just continue that arc that gave me Y, the arc will come down here and meet again the side of the triangle here at Y2. And I guess I would just ask you what the implications are there in terms of whether or not this statement is always true. I'll leave it at that.